These are notes for section 10.4 hyperbolas. Hyperbolas are once again a conic section. They're the last conic section that we will study in this course. A hyperbola looks very much like a parabola back to back with another parabola. So here's one parabola, here's another parabola. If you take two conic sections and put them point to point, and then take a cross section of those, you'll get a hyperbola. And there's different parts to the hyperbola, just like there are to the ellipse, the circle, and the parabola. So I've got several diagrams here. And there's a lot of wording with this. These are not difficult. If you can do an ellipse, you can easily do hyperbola. It's just going to take a little bit longer to explain some of the parts of it. The hyperbola has a center. So if you could imagine connecting the vertex of these two parabolas, the midpoint is going to be the center. So the center, just like with the parabola vertex, the circle and the ellipse, the center is going to be HK. It's always going to be a point. Just like an ellipse, we're going to have two different types of hyperbolas. Let me zoom in just a little bit more here. If the transverse axis is horizontal, so here's your transverse axis, it includes the vertices of the hyperbola, it includes the center. Or you can have a transverse axis that is vertical. So here's the vertical transverse axis. The transverse axis always includes the vertices, the center, and actually the focus points as well. There are two formulas. The difference between this and the ellipse is I'm still going to have an x minus h squared over a squared, but now I'm going to have a minus sign. That's the huge difference between an ellipse and hyperbola. I'm subtracting y minus k squared over b squared. The other difference is in an ellipse, a was always the larger value. And in a hyperbola, a is just always going to be the first term. So now I have y minus k squared plus x minus h squared. A squared is under the y, b squared is under the x. So if the x is first in your formula, it's the positive value. These open side to side. If the y is first and it's the positive value where x is a negative, it's going to open up and down. So now a few definitions. The vertices, the transverse axis connects the vertices. So here is a vertex here, a vertex here. Here's the transverse axis. The formulas are going to be h plus or minus ak or hk plus or minus a. A is always going to be the distance from the center to a vertex. The focus points are inside the curves of the hyperbola. Just like the parabola. So the formulas are going to be h plus or minus ck or hk plus or minus c. C is going to be the distance. Let's see if I can find it. It's down here. C is the distance from the center to the focus. From the center to the focus. And in this case, c squared is going to equal a squared plus b squared. And remember, a and b, doesn't matter which one is larger for the hyperbola, but you're going to square those values and add them, and that's where you get c. The asymptotes This is a good example of asymptotes. So what happens when I show you these, when I draw these, asymptotes are going to be like a boundary. The hyperbola can go along here, but it's never going to cross this asymptote. This one's never going to cross this asymptote. And these asymptotes are always going to be lines. So the hyperbola approaches the asymptotes. And there's formulas for these as well. So I've got y equals k plus or minus the ratio of b over a x minus h. Or, and there's a very little difference, I'll explain to you what the difference is. Y equals k plus or minus a over b x minus h. The formulas are exactly the same except for one is b over a and one is a over b. The way I remember that, when I look at these, slope is always change in y over change in x. So here you can see the b is under the y, the a is under the x. So that's this formula here. Change in y, b, over change in x, a. This formula here, a is under the y, b is under the x. So this is the one that goes with the a over b. And it just goes back to learning slope in Algebra 1. And now I'll go through a couple examples. Okay, the first example I have x minus 2 squared over 25 minus y plus 3 squared over 16. The x is the positive term, the y is the negative term. So I know this is going to open left and right. So I first have to identify my center. My center is 2, negative 3. And then I go about this the same way I would my ellipse, but I'm not going to create the ellipse. The plotting the points is going to help me create my asymptotes. So under the x is a 25, so I have to go right and left from the center 5. The square root of 25 is 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Under the y is a 16, so I have to go up and down 4. 1, 2, 3, 4. 1, 2, 3, 4. If this were a plus sign right there, that would make my ellipse. It's not going to be, but it's going to help me create the box that forms my hyperbola. So I'm going to go ahead and draw these dashed lines. I'm making them dashed lines. They're not solid lines. The solid lines are going to be for the hyperbola itself. This box that I created, this rectangle I created, is going to show me where my asymptotes go. So my asymptotes are going to connect the corners to corner. So the diagonal line, and once again this is going to be a dashed line. These are the asymptotes. Corner to corner. Now I know that I want to create my hyperbola so that it does not cross those asymptotes. Since the x is first, I told you I want to go side to side. So I'm going to start here at the vertex. I'm going to go this direction. Start at this vertex and go in this direction. So my vertices, here's a vertex point here. So 7, negative 3. Here's a vertex point here too. Negative 3, negative 3. The focus points, remember, are going to be inside here. So I need to find the value of c. So I know c squared equals 25 plus 16. 25 plus 16 is 41. So c is equal to the square root of 41. So that means from the center, I have to go a distance of the square root of 41. square root of 41, square root of 36 is 6, square root of 49 is 7, so I know it's between 6 and 7. So if I count 1, 2, 3, 4, 5, 6, 7, it's somewhere here. If I count between 6 and 7 in this direction, 1, 2, 3, 4, 5, 6, 7, it's between 6 and 7, so it's about there. So my vertices are going to be 2 plus the square root of 41, negative 3, and 2 minus the square root of 41, negative 3. My asymptotes, these dashed lines right here, it's going to be y equals k, so y equals negative 3, plus or minus. There's two lines, so I have a positive and I have a negative slope. And I said before, it's change in y over change in x. So 4 over 5, x minus 2. We'll do one more. This one has a y squared positive. It's first. The minus is on the x, so I know this one's going to open up and down. So my center is going to be 1, 0. Even the smartest people will make mistakes on this. Remember that the h is always with the x, the k is always with the y. So I'm going to plot that point 1, 0. My vertices, I have to go up and down. So I've got to go up 2 and down 2. So my vertices are these points 1, 2, and 1, negative 2. Under the x is a 36, so I'm going to go right 6 and left 6. I'm going to create this box, and all I'm going to do right now, instead of using my ruler, is I'm going to mark these corners where if I were to extend those ends, they would meet. But I am going to use a ruler to draw. It's got to go through the center. Oops, missed that a little bit. Since the y is first, I know this opens up and down, so there's a vertex there. It's going to go out and approach the asymptotes. There's a vertex there. So that's what it looks like. The focus points, I have to find the value of c. C squared is going to equal 4 plus 36. 4 plus 36 is 40. The square root of 40 is going to be 2 square roots of 10. And once again, that's between 6 and 7. So if I go from here up, 1, 2, 3, 4, 5, 6, it's between 6 and 7. Go down, 1, 2, 3, 4, 5, 6, between 6 and 7. It goes right there. And then it would be 1 plus 2 square roots of 10, comma, 1, comma, positive 2 square roots of 10, and 1 and a negative 2 square roots of 10. 1, 2, 3, 4, 5. Yeah, I marked this one wrong. It went from the center. 1, 2, 3, 4, 5, 6. That's what I thought. Okay, it's there. Let me get rid of the mistake I had made. I had paused because I knew it didn't look quite right. I couldn't figure out why. It should be symmetrical. So this distance from here to here is the square root of 40. This distance from here to here is the square root of 40. My asymptotes, y equals k. Well, in this case, k is 0. Then I have plus or minus b over a. B is always the square root of underneath the y. So 2a square root of 36 is 6. And then x minus 1. And then I would just reduce that fractions. Y equals plus or minus 1/3 x minus 1. Now I'll show you a completing the square. And this is just as simple as ellipse. The only thing you have to be wary of is that you have a minus sign here. So I'm going to put the x squareds together. So I have 4x squared and a negative x. I want to put all the x's together. 4x squared minus 8x I'm going to put the y's together. Negative 16y squared minus 160y. I'm going to put 460 on the other side. I can factor out the 4. So I have 4x squared minus 2x. I can factor out a negative 16. So negative 16 y squared plus 10y. And before you go on from here, this is where you should double check. Negative 16 times y squared is negative 16y squared. Negative 16 times a positive 10 is negative 160. If somebody makes mistakes, it's usually at this level. I'm going to complete the square. So I have 4x squared minus 2x. Half of negative 2 is negative 1. Negative 1 squared is a positive 1. Oops, minus 16. Y squared plus 10y. Half of 10 is 5. 5 squared is 25. And then be careful here. I added a 1 multiplied by a 4. I added a 25 multiplied by negative 16. Factor the left-hand side. When I combine all these numbers here, I get 64. I want this to equal 1, so I'm going to divide by 64. When I reduce this, I get x minus 1 squared over 16 minus y plus 5 squared over 4 equals 1. And there I have my hyperbola.